Thank you for joining us for our last session for today. And just before I announce our speaker, just a technical detail. This year, Innovation Zero is partnering with Ideonomy. This is a truly game-changing new startup. The Innovation Zero Ideonomy is a collaborative, innovative community that will bring people together across sectors to solve problems supported by machine learning and AI. So you will see QR codes dotted around the event where you can submit, rank, and view most important problems across each forum. And this will create a prioritized list of problems so we know where to focus our innovation efforts. After the event, we'll set up a series of new problem-solving teams where you can meet people who share the same problem, and also we'll create problem owners to solution providers so we can solve problems together, creating a new global community for positive change. So yes, please scan the QR code to get going. And our last session for today is how National Grid electricity transmission are innovating to achieve net zero. And please welcome our speaker, Gary Stockdale, Net Zero Innovation Manager, National Grid Electricity Transmission. Thank you.
Hello, hi everyone. Thank you for coming along to my talk today. I feel like you are the hardcore Innovation Zeroers, right? Because we're nearly at the end of the day. You've nearly made it to the end of the event. So thank you for coming. So yeah, I'm going to take you through a little bit around what we're doing in National Grid electricity transmission in terms of innovating for net zero. So thank you for the introduction. I lead one of our innovation teams in National Grid electricity transmission, or NGET. And yeah, I'll take you through a bit of the context as to what we're innovating in, and then give some case studies as well, just to talk about some examples of the kind of space that we're innovating in. So, just as a bit of context in terms of what NGET do, so we're one of the National Grid businesses. We operate and maintain the transmission network across England and Wales. So you can think of us as the motorways is the best analogy I like to give. We're the motorways of electricity. And then our colleagues across other networks in distribution are more like the A roads and the B roads. So we bring electricity from where it's generated across the country to our distribution colleagues, and they will then take it into homes and businesses across the country. And in terms of some of the kind of context as to why we need to innovate in NGET, you might well have seen this kind of slide in various different guises or formats. It gives a bit of a flavour for some of the context for the challenges that we face in transmission. So you can see it talks about some of the increases that we're going to see in terms of bringing renewables onto the transmission grid. So you can see offshore, solar, interconnector, battery storage increases. And then what that translates into on the picture on the right is the amount of additional capacity, so predicted upper and lower ranges for additional capacity that's going to be required on the electricity transmission system. And I should say, so this is up to 2035 in terms of what this slide is showing. But you can see some of that kind of, the upper ranges of that capacity is into the hundreds of gigawatts. And because we all love a good analogy, that 1 gigawatt is about 4,000 Tesla superchargers. Or because we're in London, to give it a nice British analogy, 1 gigawatt is about 12 million cups of tea, for example. So you can see the kind of scale of increase that we're going to be seeing in capacity. And to meet that challenge, obviously, some of the things that we're going to need to do is large volumes of construction, whether that be new overhead lines or underground cables or subsea cables, whatever the right solution is for increasing that capacity, there's going to be vast quantities of construction. So a lot of the space that we kind of innovate in is around how can we increase capacity, how can we do that quicker, how can we enable some of the construction we do, how can we make the construction greener, quicker, that kind of thing. And that leads nicely into our innovation strategy. So within NGET, we have an innovation strategy. This is essentially our 10 kind of guiding pillars. So everything we do in innovation sits in one of these key themes. I won't go through all of them, but you can see some of the things we're working in is everything from how we maintain our aging asset base. So the supergrid essentially that was built in the 60s, which is still running today. How do we maintain that into the future? Through to things like how do we deliver new onshore and offshore capacity through new technologies, for example. And those kind of examples are how we are facilitating net zero for Great Britain. We're also then using innovation to decarbonise our own operations as well. So be that through net zero construction and reducing emissions in construction, and also things like how we maintain a resilient network against cyber threats or climate threats. So that's kind of some of the space that we're innovating in. And just to give a few case studies then, I'll talk through 3 different case studies that kind of touch on some of those key themes. So the first one is all around sulfur hexafluoride. So for those of you that haven't heard of SF6, it is an insulating gas that is used across the world. It's excellent at what it does. It's a fantastic insulator. You can see, so in the picture up here, so in those pipes that you see at the top, you'll have conductor cables in there that are surrounded by SF6, which is acting as an insulator. Hopefully there's no SF6 experts in the audience, because the analogy I like to use is similar to sugar. So sugar is one of those things for most people, right? Everyone loves it. Who doesn't love a donut or a croissant or a chocolate? So it's great in that regard, but really bad when it comes to the impact it has on your body. Similarly, SF6 is excellent at insulating, but really bad for the environment. So 22,000 times the global warming effect of that of carbon dioxide. What I should say, though, is we're leaking SF6 where we do in very low quantities, so nowhere near the scale of carbon dioxide that's going into the atmosphere. But nonetheless, in National Grid, we will remove SF6 from our activities by 2050. That's the target we've set, and then we've got interim targets, so to reduce our emissions of it by 50% by 2030, for example. So that's a bit of context on SF6 and what it is, and then some of the stuff that we're doing in this space. So one is around how we seal SF6 leaks. So one of the exciting innovations we've got, working in partnership with Raw Water, is sealing leaks on small bore pipework. So SF6 leaks come in all different shapes and sizes. You can think of the small bore ones a little bit like your DIY jobs at home. It's always the case, isn't it, where you get a burst or a problem and it's just behind the wall you've just plastered and painted, and then you've got to strip it all out. Some of these are in really hard to get to places, so we've looked at innovative ways we can apply leak sealing to these locations. So what we do, you can see in the picture on the left, we have a mould that you can apply around the pipework, and then you pour an alloy in, and then you can see that alloy on the right after it's been successfully applied. And we're finding this is reducing leaks, or 95% effective in reducing the leaks we've applied it to. And this is now rolled out in business as usual within NGET. So far, we've saved the equivalent of about 1,000 cars on the road. So early days, but still really good that we're using this in NGET. We're starting to see it being adopted across other networks as well. So a distribution company have also used it to fix one of their leaks. So it's part of our kind of toolkit in terms of how we fix fix SF6 leaks. We're also looking at, obviously leaks is only one part, the outright replacement, so alternatives and retrofilling SF6, so how we can put SF6 back into the existing assets that we've got is another thing we're looking at. So we're doing quite a lot of work on what's the kind of long-term asset kind of management practices that we need to do for the assets that we're going to retrofill with different gases. So C4F7N is a replacement to SF6, for example. It's much lower global warming potential. So we're looking at, like I say, what's the long-term plan and what do we need to know and do in terms of how we maintain assets that are going to be filled with that instead of SF6 as an example. So lots going on in that kind of space there. Moving on to a different example then. So I touched on earlier how construction is going to be one of the biggest challenges for NGET. The sheer scale and quantity that we're going to need to do over the coming years is, as you can imagine, pretty mammoth. So we're doing a lot in the innovation space around net zero construction. So that's looking at alternative materials or alternative techniques to construction. How do you make it quicker and faster? Those kind of things. So this is an example of some of the projects we're doing at the moment in our innovation team. So looking at different materials. Again, I'm not going to go through all of these, but things like graphene enhanced concrete. We think that has potential to be like a strong concrete. It cures very quickly, potentially, versus other greener concretes. Things like 3D printing, construction materials as well, which can be useful for reducing the wastage that you get in concrete that you pour. So we're looking at these kind of things, and we're looking at the feasibility of how practical they are for NGET. So what's the strength once the concrete's cured, for example? What's the weight, the carbon footprint? How easy is it to use in construction? And we're working with various construction projects to actually trial and demonstrate, as well as the feasibility of some of these. And then, the plan is that we would then use the ones that are successful in the future construction projects that we're doing. And then my final example is a little bit of a different tangent again. So this is all around how we automate the inspection of our assets. And I guess some of the key themes here, like again, there's a common theme here in terms of the assets that we've got already, but also the scale of the assets we're going to need to build in the future. We need more effective ways to autonomously monitor those assets. So this project in particular is working with partners Seize AI and Keen AI, looking at how we use drones and AI to autonomously inspect our assets. So just to put it into context again, we've got about 22,000 transmission towers across England and Wales, about 49,000 across the whole of the UK, including our colleagues in Scotland. And towers obviously age. They're made of steel. They corrode over time. With proper maintenance, you can get them to last about 100 years, which is pretty impressive. But you need to obviously undertake all of the condition monitoring that comes with that. You need to paint the towers if they're corroded. If they get too corroded, you need to replace them, which we obviously want to avoid. So this project is using, or what I should say actually is our typical current practice is using helicopters. So we will fly helicopters around. We will take images of the towers, and then we will have a team that analyze those images and grade the corrosion, and then that then informs what the corrective action or measure is, or what the maintenance needs to be. What we're doing in this project is using drones that can fly beyond visual line of sight, so without having to actually be there on site with a drone. It will take images of the tower, and then it will use AI and machine learning to then identify those corrosion areas. And then what we're doing with the current project we're working on is taking that a step further as well, so how we can use that AI and that machine learning to not only identify the corrosion, but actually grade it and predict what the future corrosion is going to look like, so we can be better informed in terms of our asset maintenance. And then that obviously has benefits around, it reduces the reliance we have on our helicopter fleet, which is obviously a fuel saving. I think some of the more kind of exciting and bigger benefit is around, again, going back to that additional infrastructure we're going to need to build over in the future. This kind of technique will help us keep up with the throughput of monitoring that we're going to need to do to help maintain all of the assets essentially that are going to be bringing renewable energy back across Great Britain. And we want to take this one step further as well. So some of that kind of future ambition is, and you have to run with me on this one because it's a bit cheesy, but almost have we call it maybe like a self-healing network. So a network that autonomously we can do the inspections, and not just on tower steelwork. So that might be wider, it might be insulators, it might be fittings, it might be substation equipment, but autonomously do the inspections and then have whatever it is in the background, be that like the AI or the machine learning, then helping inform us in terms of the right asset management decisions essentially. And then, like I say, thereby enabling us to maintain that network of the future that we're going to be building as well as the existing one. So that was it in terms of my bit of a whistle stop in terms of some of the context and some case studies. Hopefully doing good for time. And yeah, happy to take any quick questions. So thank you.
Thanks for the presentation. If you have several proposed solutions addressing a particular challenge, so how do you prioritize?
So you're talking about like if we've got several solutions for a particular innovation challenge?
Yes. How do you prioritize?
Okay. So some of that, if you take it back a step further, we've got lots of methods to kind of find the innovation that we need. So if we've got a particular challenge, we might work with some of our partners, we might work with procurement. That can help us kind of find some of the solutions that might be on the market or that might be there that can then help us address some of those challenges. And then in terms of some of the prioritization, we've got a wide team of very competent engineers that will do kind of like an initial pass of some of the innovations that we're doing. We carry out things like cost-benefit analysis. So any ideas that come in, we will look at like, what do we do today versus what could be in the future and what's the benefit? We've got options, again, if there's multiple options that look feasible, we might look to do a consortium or a collaborative project. We have processes in place within the business as well in terms of how we sanction innovation. So it goes through various review panels that can then help review and challenge essentially, is that the right thing to be doing? So those are kind of some of the steps that we'll go through essentially. We also work quite closely with other networks through the ENA, for example. So other transmission networks, other distribution networks and gas, who again provide some of that kind of challenge and rationalisation around, are you doing the right thing? It might be that there's opportunities for collaboration, might be that there's duplication, so we don't go ahead with a project. So lots of kind of steps and sense checks in terms of how we might find and prioritise innovation. Hopefully that answers the question.
Hi, great session. Actually, very impressed with the innovation National Grid is bringing. So just if you can share maybe 2 or 3 things you are thinking of, let's say implementing this year or next year around sustainability, making National Grid more sustainable. That could be very useful for us to understand.
In terms of implementing, did you say?
What may be the few things you may think of implementing this year or next year?
Yeah.
Maybe
okay.
2 or 3 projects or...
Yeah. So these are some of the ones I've touched on are good examples. So the SF6 leak sealing, that is implemented now. We use that as business as usual. The VICAP project that I touched on last, that is due to be going live imminently in the next few months, where our condition monitoring team will start to use those techniques. The net zero construction is probably a little bit further off. So we're either in the space of doing feasibility to understand are these solutions even viable or not for the needs that we have. Some of them, like the 3D printing of foundations that you saw, that is going to be tested on some live construction sites that we've got. We're looking at similar things around like diesel-free construction, for example. So yeah, hopefully that gives like a little bit of a flavour of some of the things that we're doing in terms of implementation. We're coming to the point as well, like in our regulatory period, where a lot of our innovation projects are closing over the coming years. So there's quite a big focus at the moment on what we're rolling out essentially into our next regulatory period. So yeah, that's some of the things that we're kind of looking at in terms of some of the stuff I've shared up there. There's quite a few other bits, not always necessarily around like sustainability, that we're looking at as well. So we've got one around resilience. So we've got a tool that helps look at like flooding resilience and coastal erosion or river erosion, and the impact that it has on our assets. So we've got a tool that is going to be going live into our control centre later this year. That will help give the control centre more kind of tactical information on incoming weather risks, what risk that's going to have to our substations. It will kind of help assign a risk rating, and that then helps them incident manage, like where are we likely to have impacts on the network, where's going to be less risk, essentially. So things like that going live later in the year. So yeah, hopefully it gives a little bit of a flavour.
Yeah, 3 quick questions. Firstly, a follow-up on the regulation. What are the key regulation that you're focused on? Also, in terms of the portfolio of electricity, like in 2030, what's going to be your like diversity of sources for electricity? And recently in the news, like AI has kind of distorted the projections of electricity. Is that actually the case? Thanks.
So I'll take those. You might have to refresh me in a second if I forget the final one. The first one was around regulation, wasn't it? So depends in what regard, because there's a few areas. Like in terms of a lot of our innovation is done through regulatory funding, for example. First thing to touch on quickly. So we use funding mechanisms like the Strategic Innovation Fund and the Network Innovation Allowance. Those are funds that are administered by Ofgem and then topped up by networks, and that allows us to do innovation in this space essentially. It is a really important enabler for us. I'll be honest, I'm happy to catch up after. Maybe the like wider question around regulation, probably not the best place to answer. Second question was around what do you see coming onto the grid by 2030? Is it in terms of renewable sources? Are you thinking like some of the things I shared on the slide around like wind, solar, those kind of things? So yeah, I guess going back to scroll back up quickly. Those ones that were called out on the slide are some of the main key ones. There we go. And hopefully the infographic kind of helps. So yeah, increases in things like offshore wind, solar, interconnectors, and battery storage. So offshore wind is obviously going to be growing, and we need to be focusing on how we can bring that down, particularly where it's produced off Scotland and bringing it down to England. You'll see an increase in interconnectors, and that's not just between like UK and Europe, for example. That might be between, let's say, subsea cables between Scotland and England, or between different areas of England, essentially, to bring energy. Battery storage is another one. So I know recently, I don't know all the details, but I know recently we've unlocked quite an amount of additional battery storage capacity that's gone onto the network in terms of managing that connections queue. So yeah, again, don't know if that answers the question. And I can't remember the third one. You might have to refresh me if you wanted to touch on that one quickly.
Yeah, just in terms of the news, it said that AI is kind of 3x electricity than projected. Do you think that is the case, or is it just inflated? Yeah.
So, well, I probably can't answer the question directly. I don't know if that's how much additional capacity it will be. But I guess what I can say from an innovation point of view is that it is something we're interested in. We talk a lot about like whole systems in innovation, which is a bit buzzwordy again. It means different things to different people, but kind of looking at the holistic. So outside of just transmission, who else do we need to coordinate with to make sure we're building the network of the future? So one of the things we are talking about at the moment is there kind of potential for an innovation project with data centers being kind of at the heart of it, trying to understand what are the impacts going to be on a transmission grid. I'm sure our customer connections team who manage that whole process are doing work on this as well. I can't talk for them. But from an innovation point of view, we have spoke to them about helping them on that journey, but also how can we perhaps help work with some of the data center providers to kind of help where they would be in the country to try and manage that capacity? So could we help inform, a cluster or spread of data centers across the country rather than all in one location to try and help manage that capacity? So those are some of the things we're going to be looking at.
Thank you very much. Brilliant presentation. Obviously, lots of time, effort is spent and money spent on these projects. Is there any mechanism in National Grid to sell it back to other markets in the world?
You got the tricky questions there. In terms of, are you thinking in terms of commercialization of technology?
Those drones or pollution monitoring systems, obviously they're very clever and enhance the operations team capability. So if we can sell it back to other partners across Asia, Africa, or
So there's okay. I'll have a go. There is some nuance in the question. In the first thing I'll start with is those funding mechanisms I talked about, so SIF and NIA, they're quite clear in terms of some of the kind of commercialities around it. So an Ofgem helped define some of what that needs to look like. So NIA, for example, I believe is 50-50 split for IP, for example, for foreground IP that's developed through the project. And some of the thinking behind that is if consumer money is going to be spent on helping develop some of these technologies, then consumers need to benefit from some of this, whether that's be through the efficiencies we make in terms of how we operate the network, essentially. So some of that will go back to the consumers in terms of saving on the bills. Then obviously we do work with lots of different suppliers who will then, and some of that might be helping scale the technology that they're working on. And then, they might be able to then, that might help them scale in terms of how they can then deploy that wider, be that across the UK or globally. Again, those funding mechanisms, the NIA and the SIF that I talked about, are very much about sharing. So if NGET, for example, do a project in a particular space, we do, and we are obliged to share that learning from the project. So we will share that with other transmission companies, with the distribution companies. And case in point, I guess, is raw water is a good one. The one I talked about around SF6 leak sealing. So we've deployed it within NGET. That's also now being deployed within DNOs, for example. I don't know all the details of the commercials, but that sharing is a big aspect and a requirement of the funding that we have.
Thank you.
Hi.
Hello.
We're going over time, but
That's all right.
in terms of transmission distribution losses, is that something that you can innovate to reduce or nullify, or is that always going to be an inevitable consequence of transporting electricity around the UK?
Is that transmission distribution losses, did you say?
Which is about 2% of generation.
Okay. I'll be totally honest, actually. I'm not sure I'll be able to answer the question. I might have to pass on that one. Or we can catch up after and I'll find someone that can help. I don't want to give you information that's either wrong or I'm just making it up. So apologies on that one. I'm being honest. Apologies. We can have a catch up afterwards to see if we can find someone that might be able to help. Sorry about that. anymore for anymore. Everyone's now thinking, I'm going to get home for my dinner now. But yeah, genuinely, thank you for coming. I know this was right at the end of the day, so thank you. And hopefully that's been useful. Thank you all.
Thank you very much, Gary. That was a great last session, very engaging. So that was our last session for today. So please enjoy the rest of your day. Thank you.